Using the performance analysis tab, you can run a few simple performance analysis, and you can plot things like thrust versus forward velocity or total power versus forward velocity. And it is as simple as clicking here in order to add a chart, and you just press the Analyze button and you will get those plots. And what you see here is a plot for torque versus velocity. Here's a plot for thrust versus velocity. And here's another plot for total power versus forward velocity. For instance, in this case, the hover power is around 550 horsepower. And at 140 knots, you have a horsepower which is close to 1,000 horsepower. So at the same time, you will have some numbers here, like the maximum velocity. The maximum velocity is, of course, based on the power available you put here on this chart here. So an interesting plot would be to run a total power plot versus forward velocity. Let's include all of them: the induced velocity, the induced power, profile power, parasite power, and the power available. The power available is, of course, my input here is 850 horsepower for this case. You can run an operating altitude. For instance, you can say, what would the power curve look like at 10,000 feet? And you could even include an additional temperature. This is the standard atmospheric temperature at that altitude, plus an additional temperature if you want to add an extra temperature here. So all you need to do is now press Analyze, and you have this big plot that includes all of these performance variables. So let's make it a little larger, and you see the total power here. That's the blue line, and this is your power available. That would be the red line. So your maximum speed would be somewhere around here, which is 100, maybe 130 or 128 knots. So for hover, on the other hand, you will need a horsepower that's close to, let's say, 700 horsepower here, right? And the induced power and parasite power, profile power, and so on, you see all in this chart at once. Now, once you have this chart, of course, you can print it, or you can save it as an image if you want to use it somewhere else. Aside from these plots, you see these maximum velocities. Of course, 126, that was based on the power available we introduced, and the power that you calculated, that the calculation was at 843. That's where it stopped. In fact, the calculations from 0 knots to let's say 140 knots. In this case, the chart is from 0 to 140 knots. The increments for these calculations is every 1 knot. So at 126 knots, you had 843 horsepower, which means at 127 knots, you probably had more than 850. That's why it stopped at 126 knots. Similarly, the minimum velocity is obviously 0 knots. That would be the hover performance. This is useful in case your power available is not enough to hover. In that case, it will give you the minimum velocity at which the airplane, the helicopter can fly, since it cannot hover. All right. A nice feature here is, of course, also the operation altitude, and based on the temperature, Heli-Dyn will calculate atmospheric conditions for you. So you will see what the atmospheric pressure is, what the density at that altitude and at certain temperature will be, the density and the temperature we are adding at that particular altitude. The Heli-Dyn has a nice atmospheric model inside, so it will calculate the density, the temperature, and the pressure at that altitude, and the temperature you're adding here. For instance, let's say you have a hot day at 30 degrees Celsius, an additional 30 degrees Celsius, of course, and you will immediately see the calculated atmospheric conditions at that particular point. If you do that, let's put it at 30. You say analyze, and you will immediately see the temperature, the density, and the pressure Heli-Dyn used for its calculations for power. You can do a similar plot for thrust and torque. And this turned out to be a handy tool to quickly calculate the power required, or the operation ceiling for a helicopter if you want to make these fast calculations. There's using these power plots, you can calculate the maximum range velocity, which happens to be at 97 knots, and the maximum endurance velocity, which is the point where you use minimum power, and that turned out to be at 60 knots for this particular helicopter. And in fact, the power at that minimum, the minimum power you require for this helicopter to fly would be 486 horsepower. So this is pretty much what we have for the performance analysis.